All right, welcome everyone to the Cleveland R user group. Today we have two talks, one by Jay Ranchod and one by Bryan Lewis. So we're going to start off with Jay. He's a financial analyst at Rose Community Management, and he's going to talk to us about extracting tax data from PDF files. So Jay, go ahead and share your screen.
All right, yeah, thank you, John. So like John said, my name is Jay Ranchod. I'm a financial and operations analyst at Rose Community Management. We are a real estate management company based in Independence, Ohio, and we manage about 60 properties at any one time. There's quite a bit coming in and going out of the pipeline, but that's about our volume right now. And so just so everyone kind of gets their heads in the real estate space to kind of motivate the problem, there's this concept of a wait list, right? So you apply to a unit, you apply to be in an apartment building.
And do you have slides to show? Because we're just seeing Zoom.
No, I was going to pull up this first. Can you guys see this PDF? Yeah, I don't have, I'm not doing slides. I was just going to do a demo.
We can see it, yeah.
Okay. So this, by the way, this is what Greg helped me with. This is all fake data. This is nothing remotely related to any real people for obvious reasons. And so at any given property, you might have a wait list. You might have people saying, well, you know, I want to live here. Well, we can't get you on right now, but we're going to put you on this wait list. And the interesting thing here is that your position is related to the kind of unit you are applying to. So you might have a 1-bedroom, a 2-bedroom, a 3-bedroom, or a loft or an efficiency, which we would just say is 0. And for the 60 properties that we manage, the president of the management company came to me and he said, okay, I want to see each property is its own row, and then I want to see how many applicants are on the wait list for loft, 1-bedroom, 2-bedroom, 3-bedroom, all the way down, which you would think is a fairly rudimentary request, but given some issues we're having with our software vendor was actually unable to produce that for us. And we were actually unable to even get Excel files of individual properties. The best we could get was 1 PDF file per property. And so that's kind of where we're starting with. So I merged those into one big PDF file. Again, this is just the one fake property with entirely fabricated data that we're going to be going through. But I'm just going to walk through the script step by step because it's actually not terribly complicated. So it shouldn't be terribly long. So the first thing is to get your necessary packages. I absolutely cannot work without the pipe function, so I always bring dplyr. And the PDFTools function is really kind of the secret sauce here. That's going to let you interface with PDF files in a functional way. And by the way, if anyone has questions or comments or anything, please don't hesitate to speak up. So the first thing you have to do is just read in your PDF. And when you use this PDF text function here, you just call the file path that you're using, and it will make a character vector with a length equal to the number of pages. So in this particular, case, I'm going to say 2 because we do technically have 2 pages here. And that's a great start, but it's not necessarily super duper helpful. So if you look at first page, for example, this is all the text in the first page. And that's not really very useful, but what you notice is there's a line break here. At every line, there's a break, RN. Now, I just helped my boss get set up with this script, and you may actually just have the /n, \n. So just, if you do decide to start using this for anything, just kind of keep an eye out for, exactly what that line break is. But in this case, it's RN, and we use string split, and want to unlist it. And this unlist part is actually really important because if you don't, then it's going to keep the type of list. And that's I don't know, maybe you like lists, but it's really not my favorite to work with. And another little component here is when I'm building these scripts out for the first time, I always like to kind of, at different chunks change the name of the object I'm working with, because that way if something gets messed up, I don't have to go all the way back. That's realistically not something I need to keep in production, but a lot of times the scripts I actually work with will do this just because I never really take it out. So here we see test, and if I can type it correctly, you'll see now we have one for each row on the document. So this is a little bit closer to where we need to be. So the next part is kind of the odd piece when you're trying to deal with multiple properties combined into one file. So what I'm going to try to do is I'm going to try to say, okay, so let's say we have Suncrest Heights, right? When I'm looking for waitlist applicants associated with Suncrest Heights, I only want to be searching between this row here and this very bottom row here, because otherwise I might end up with applicants for other properties. Again, when you're only doing a one property example, you don't really need to go through this, but if you want to aggregate these files and really kind of automate the process, this part's going to become necessary. And so we're going to be creating an index, basically, just two values that say, hey, if you want to find applicants for Suncrest Heights, you have to look after this row and before this row, and that's where you're going to find those applicants. So that's easy enough to get started with, right? Because all you need then is the index of where you actually see the word Suncrest Heights. And quick poll, is anyone not familiar with grepl? I can't see you guys while I'm sharing, so I'm going to assume everyone is. String matching and partial string matching, which is necessary for dealing with these kinds of text files, unfortunately. Or fortunately, I think it's cool. It can be complicated, though. So this gives you the indices where the name Suncrest Heights actually appears, which is nice because you get this one right off the bat, right? You get the beginning basically for free. And you also get the top of the second sheet. Now this is cool because you get, like I said, you just get the beginning, you get the top of every sheet, you get the top of the last sheet. But then applicants on your last sheet might be left out if you just stop there. So if you Suncrest Heights Vec, so we can see rows number 1 and 45. And that's good, but we got to keep going. And so this is where there's kind of a, I would call it like a college sophomore-y, you know, kind of duct tape fix. So some properties may not actually have any values because they may not actually have a report in this reporting dump that we're doing. That's kind of a quirk of our vendor's software and not really something I should probably go into right now. But all we're doing is we're saying, okay, start here, start at the last time you got the property name, and then just go until you get to the text income status. And the reason I say this is kind of a hacky approach is because I'm relying on that idiosyncrasy of this PDF file. I'm relying on this text being at the bottom of every page. So if our vendor ever actually changed this up, I would have to adapt for it, which again isn't ideal, but neither is trying to pull tabular data out of a PDF because your vendor can't give you spreadsheets. So, you know, here we are. So that, if we run this loop with this little empty wrapper on it, then you see that it's actually updated. So now we know that we need to search for Suncrest Heights. We need to search between rows number 1 and number 58. And that's going to give us the entire population of Suncrest Heights. So now we actually know where we're looking. It's time to figure out what we want to actually look for. So defining a search range. So this is where things get even more interesting. So I'll kind of pull this back so you guys can see. So what we're doing is we're going to create these objects that contain the number of applicants for a loft, for a 1-bedroom, 2-bedroom, and 3-bedroom. And we're going to be, again, this is just kind of the is empty wrapper that is really not the interesting part of this. And so we're going to be searching through the minimum and the maximum of that vector. And yeah, I know a lot of people probably aren't used to seeing for loops in R, but just go with me on it for now. So we're going to be, in this case, this is going to be 1 through 58. You could, again, if you have multiple properties lined up here, then it could be any number through any number. And that's the entire point. We're just defining the range that we want our partial string matching to trawl through. So this partial string matching if statement is a little bit involved, and it's kind of difficult to dive all the way into the details, but basically what we're saying is there are certain status indicators like A, P, O, and this 0 indicates the room or the number of bedrooms. So we're saying if it starts with this pattern with a 0, then we know it's related to a loft or an efficiency apartment. We want to make sure we're including an existing resident transfer. So if there's someone who's living in one apartment and they want to move to another apartment in the same building, we don't count that person as being actually on the wait list, at least for our management purposes. And these are the A, the O, and the P are status indicators that we want to include. So O, A, etc. We know we want to include that person, and we know we want to exclude existing resident transfers. So this loop just pulls everything out of that vector, that character vector. And then all that's really left to do is pull it into a nice tabular format. It's more impressive, again, if you're doing 60 at a time, it looks cooler. But again, with one example, this is where you end up with. So to recap, the basic process is you take your PDF, you break it down into lines, then you use partial string matching to define the indices, or I've recently heard it called indexes too. I was always taught indices, but in any case, you define the indices where you want to search for each given property, and then in that range, you trawl through with another partial string matching function or set of functions, and then just count up all the hits you get. So does anyone have any questions, comments, immediate reactions? Once.
What comes to my mind is how often do you have to run this? Like, how much time are you saving yourself? Because obviously, if you had to do that 60 times,
once a week.
Yeah, that would be. So you're saving an amazing amount of time. And how long is that? Like 100 lines? How long is that script?
Oh, well, that was 100 lines for one property. But since it's string matching on each individual property, when I do it for 60, it's 2,000 or 3,000, I think.
I see, but you copy paste it. You could find it, yeah.
Yeah, no, that's not. I mean, it took a little while, but the options were tell my boss's boss that we can't do the thing he wants, which is never ideal, right? Mm-hmm. Or just literally sit there with a big pile of PDFs once a week and count stuff, and we're not doing that. So this turned out to be the best solution. I think there are commercially available like AI systems that can read PDFs for certain things, but they're already paying me, so.
Well, it's usually a bespoke format, right? So you probably have to do a lot of work post that anyway, so you're just getting it right away.
Yeah, I mean that's the trick. It's the blessing and the curse of individual formatting is you gotta learn to play with what you got.
Sorry, I had one question. I thought you mentioned at the beginning that each property came as a PDF file and you collapse them in one big file, and then you're running your script. So
yes.
But from your code, it seemed that a big chunk of it is to split the big PDF file into property-related sections. So I was wondering, why did you then merge all the PDF in one file? Why didn't you just process each PDF separately?
So there are a couple of reasons. First of all, if you could write a function to upload each file and run it through these functions separately, but the struggle is that given the use of the property's name in the string, in part of the string matching function, you can't define something as a variable and then put that into the actual string you're trying to match on in string matching. So I was going to have to do a lot of this anyway, and I would rather just avoid the step of having to worry about the function getting all of the right files from the dump. Because the other thing that I'm doing is I'm keeping records of all of the files that I'm using. So this is part of a larger report. And when I make my weekly report, I keep records of all the files I used. So that way, if somebody comes back and says, hey, I'm the property manager of, Suncrest Heights, and this number for my wait list looks a little weird, what's going on here? It's easier for me to just have one direct reference file opened up and show them what's going on. So, it's a little bit about duplication. It's a little bit about keeping things for posterity. And I mean, really, breaking things down by string. Like I would have to, get those row numbers anyway, right? So even in this one example, I have to make sure I'm getting all of the residents off that last page. So I have to do that whole index set anyway. So it's really not that much additional work. And I for our business situation, the benefits make sense. But it's a good question though, because that is kind of an idiosyncrasy of this particular business process.
Thank you.
Bryan, did you have something you were going to add?
Oh yeah, no, I was just, I mean, the format's coming in all over the place. That they probably change over time too, is my guess. They don't stick with one. I mean, I've seen this all the time.
Well, that's entirely possible. This was really built, as so many things in life, this was built as a very short-term temporary situation until our vendor got the tabular format ready from their software platform to begin with. That was about 9 months ago. So yes, you are absolutely right. It is entirely possible that the format would shift, and there is a real risk of shifting format costing us time on my end. The perhaps naive assumption, hope, if you will, is that before that becomes an issue, our vendor will make the tabular format available, and I won't even have to do this at all. This is absolutely the last option for us. So yeah, that's a real risk, but the problem is supposed to be just moved off the board entirely. Although again, I've been saying that for the better part of a year, so who knows?
I think it's a startup idea for you, right? So make like a shiny app that has a harmonized property management interface format that everybody can use to submit electronic statements in a uniform way, and then sell that to all the managers across the whole country. Sounds like a great startup to me.
That's an awesome idea. I'd be really interested in making that. That's really cool.
Yeah, there's a company in Columbus. Have you ever heard of Cover My Meds?
I have, yeah.
So they were down. Yeah, you worked for Epic before, right? Yeah. So Cover My Meds, yeah. Right? They're a company that was sold to McKesson, I think, for like $2 billion last year in Columbus.
Wait, McKesson bought Cover My Meds? I didn't know that.
They did.
Like, or it's McKesson a different?
Yeah,
okay.
McKesson, however you say it, right? Yeah, and that was their business. I knew some of the founders, right? And that was the startup, right? Just a uniform format for submitting forms for RX, for doctors, for independent doctors' offices, right? Instead of just faxing papers that are all different. $2 billion. So there you go.
I could use that.
Cover My Meds.
That's an awesome idea. I'll have to look into that. Thank you. All right. Well, if that is the last of the questions, thank you all very much. I think, John, are we going to go straight into Bryan's?
Yep, we'll switch over. Thanks so much, Jay.
All righty. Yeah, you're very welcome.
People have any lingering questions, they can throw them in the chat. But yeah, next up we have Bryan Lewis, longtime Cleveland R user group member, a longtime R user. his true bio would take too long. So, so mention a few of his
only because
highlights.
I'm old.
Accomplished. You gotta know how to spin it. So he's author of two very popular packages, the IRLBA and 3JS packages. And then his background is in mathematics and in finance, but he's dabbled in lots of different things. So excited to have him here today to tell us about this new data in-memory database called DuckDB. So take it away, Bryan.
Okay, so I'm going to try and share the screen. Host disabled. I had to rejoin the meeting, so I think.
Oh, okay, yeah, I made you co-host right at the beginning.
Yeah.
All right, try again, Bryan.
All right, there we go. Share. Can you see that?
Yep, we see it.
Okay, this is pretty short. I cut things down, but I have links to a lot more details. So I'll introduce you all to DuckDB. It's a new embedded database, and I'll explain what that means. It's pretty cool. But first, who wrote it? It's primarily Mark Rosvelt and Hannes Moelhuizen from CWI. So CWI is the Dutch National Research Institute for Math and Computer Science. These are serious people. And kind of a famous database quite a while ago now that came out of CWI is the one you may have heard of. It's called MonetDB. It's a very popular open source columnar database, kind of the open source version of Vertica, basically. And DuckDB is a new embedded database from the same group. And Hannes in particular, you may have heard his name. He's been involved with R and the R community for a long time, largely around his really kind of path-breaking work on deep integration between MonetDB and R. It was really, really cool stuff. So you guys can hear me okay, right? I'm not, is that right? Okay,
yeah,
good.
You're coming in clear.
I'm not in Cleveland right now. I'm out in Appalachia and the internet is terrible. All right, so what is it? So they call it SQLite for analytics. It's quite new. It's only been around for a short while. And it's an embedded database. And an embedded database means it's not a separate program. There's no server to connect to. It just loads as a package in R, and then R becomes the database. You just use it directly. There's no separate anything. There's no dependencies. There's no configuration. You just install packages DuckDB, and you're ready to go with a full-blown relational database that can run SQL and all that jazz. And the data can be done in memory, or you can store data in files, and it can read from files too if you want to do that. But of course, so can R. So far, that is the same as SQLite. You probably heard of SQLite. SQLite is one of the top 3 most widely used programs on Earth. It has something like 1 trillion deployments. It's ridiculous, truly. It's in every Android phone, every iPhone, probably every car. It's everywhere, basically. The difference between SQLite and DuckDB, or one of the differences, is that SQLite stores data kind of the old-fashioned transaction processing way, where all the data are stored row-wise in memory in the database. And unlike SQLite, DuckDB stores data in a columnar format. Its tables are stored column by column in memory, which is exactly how R stores data in memory for data frames. So it's well suited to kind of working together with R. And it's really good if you're working on problems where you need to pull out the data for a column and work on it as one unit instead of having to go iterate over a bunch of rows. You just get it in one blob. So that's why they call it kind of an analytic database. And as you'll see, it has some pretty interesting and really deep integration with R and Python too. So we start with a trivial example, really, in SQL. If you've done the install packages DuckDB, you can load it as a library, and then I'm pulling in a data frame called flights from this package NYC flights 13 in the next line. It's just a data frame that's got like a ton of data associated with every flight for 1 year out of 3 New York area airports. And then there's a couple of lines in the middle about connecting to DuckDB, firing it up and registering it. I'll talk more about that in 1 second. But then you can just run a SQL query right on that data frame. So here, this is just a normal kind of SQL query. And all this does is it counts every flight coming out of every origin airport for the whole year, or for however long the data frame is listed. And we see there's 3 airports in here, Newark, LaGuardia, and JFK, and there's the count of every flight that departed those airports. The most impressive line on this screen is the highlighted one. It's this DuckDB register. So normally when you load a database in R, like Postgres, you connect to Postgres or whatever, SQLite or anything. If you want to take an R data frame and then work on it in the database, you got to somehow copy it into the memory of the database program. And that's true of SQLite too, even though it's an embedded database, because it stores the data differently than R, it still has to make a copy. But DuckDB uses alt-rep and all kinds of new stuff to deeply integrate with R. You can register a data frame, in this case, flights. It's just a regular old R data frame. You can register that with the database, and then in many cases, the database can work directly on the data frame in memory without copying it, just in your R session directly on it, which is the only database I know of that can do that. It's actually pretty impressive. And I said it most of the time. In this example, it actually turns out it can't do that because this is only using character valued data, and you may or may not know that character valued columns and data frames in R are stored a very special way, and by R it's rather custom, and the database actually had to make a few copies, but it does that behind the scenes. You don't know about that. But that's kind of a cool and interesting thing about DuckDB. Now, I said you can run these SQL queries. The whole rest of what I'm going to talk about is basically don't run SQL, like, ever. And I hope I can make the case for that. I'm not saying don't run DuckDB. I'm just saying avoid the SQL part of it, and you'll see what I mean. So that was a really easy SQL query. We're just doing a grouped aggregate, they would call it, right? We're just adding up all the counts of something by airport. So here's another simple question that you might ask of these airport data. For every one of those, LaGuardia, Newark, and JFK, those origin airports, what are the top 3 destinations that they flew to? Pretty easy question to state. And in R, anyway, that's a really easy question to answer. You can answer it a million different ways in R. Here's a base R way of doing it. And the base R approach, there's many base R approaches, but this approach just works by splitting up the destination flights by origin and mapping a function over it. The function just counts each destination up, sorts them, and returns the names of the top 3. And you get back a list out of this. This is not a tidy data approach because it's returning something that's not a data frame. But it is an efficient and simple base R way to do it. If you prefer the tidy data way, as Jay might, the dplyr approach is equally simple, perhaps easier to read, probably runs faster. And you just load up dplyr. So for those of you who don't know what dplyr is, it was mentioned in the previous talk quite a few times. Dplyr is a grammar for data manipulation that's very carefully thought through. But it's actually a lot more than that, and we'll see some really cool things there in a moment. But with dplyr, you would just take that data frame flights, group it by origin, count the destinations, sort them, take the top 3, and return just the 2 columns that we're interested in. We get back the same output in data frame form this time. Is that okay for everybody so far? Pretty basic data munging stuff. So how would you write that query? And does anyone here use SQL a lot?
Yes.
Yes. Can you write that query in SQL?
Yeah, so
it's a trick question. Here's the answer. It's a rhetorical question, I should say. And here's the answer is surprisingly complicated. in SQL. Now this is ANSI SQL, I should say. This is standard SQL that'll run on pretty much any database. Many other data, there are plenty of commercial and even non-commercial databases that have non-SQL custom approaches to solving problems like this, but that's not SQL anymore. That's some sort of variant of SQL that's used only by Postgres or only by Oracle or only by Microsoft SQL Server. If you want to solve this problem in SQL, it's surprising to me, at least, how difficult it is to solve that problem. And this is the query to do that. You can write this query a number of different ways, but the query, it will just look differently. I mean, it's just basically the same query. I don't want to go into all the gory details of that, but you can ask me questions about it later if you want to. And you get the same output if you run this query. I ran that query through DuckDB using this db get query function, and we get the same output. So it actually is the same result, but with a pretty horrible way of expressing it compared to dplyr anyway. This is an observation that I've made over and over again in my many years working with databases and R. Things that are simple in R, and to a large extent also Python, can be extremely difficult in SQL. Not impossible, because these days SQL is recursive, and so it's Turing complete. You can actually do anything in SQL, but you probably shouldn't do anything in SQL. So simple data manipulation in R and Python can be pretty tricky in SQL. And in my opinion, the converse is never true, really. There's nothing that's simple in SQL that's hard in R. So that's one of my kind of life observations there. And the good news is DuckDB works really nicely with dplyr. You don't have to even think about SQL. You can just, instead of starting with a data frame, you can start with a registered database in DuckDB. In this case, we called it flights. This is a table that's sitting in DuckDB now. It's actually a pointer back into a data frame that's in R. And we can run through a bunch of just standard dplyr stuff. I had to change one line from head to use this slice max for a technical reason in dplyr that I've discussed recently with Hadley. But it's basically just standard dplyr. It mostly just the stuff. Well, it is just standard dplyr. There's a few things in dplyr that you have to change wording with to get to work with SQL backends. But the nice news is you don't have to use SQL. You can just use dplyr, and dplyr will take care of it for you. It'll run it in the database and let the database do its optimizations or whatever. So you don't even have to know SQL, and you probably shouldn't know SQL. Which leads to a question like when or how, or both, when and how, is it useful to have something like DuckDB for an R user? When should you use something like that? And I've been thinking about that problem quite a bit the last couple of weeks in particular. And I've been thinking about it largely along two facets. Like how should you use DuckDB, which I've approached as largely a syntactical problem, versus when should you use something like DuckDB, which usually boils down to some kind of a performance issue. And so on the syntax side of things, my advice is this. And look, this is, this may offend SQL jockeys' sensibilities, but as the Big Lebowski said, this is just like my opinion, man. In my opinion, data manipulation in R is easier, and with dplyr, it's more universal than it is in SQL. So you should always start thinking about problems with R. Don't start with SQL, start with R, and add dplyr and data table and whatever other things you need to add to solve your problems that you would normally use in R as you need to. But if you do think you'll need to incorporate a database into your workflow, stick with thinking about problems largely the dplyr way, because then that will give you close to zero friction to just move right over to running those same problems on the database without having to rewrite anything. And the benefit there is you just have less stuff to think about. You just have to think about R and dplyr, and you're good to go. Now I'm going to sledgehammer this syntax stuff over your heads. I'm just going to beat you over the head with SQL syntax. So here's another example. that is easy. It's an easy thing to state and an easy question to ask. And it's commonly known as an as-of join. It comes from time series analysis problems, which crop up in, like metrics, data logging, remote sensing, finance, communications. They pop up all over the place, right? Basically, anytime you have a timestamp on data, it doesn't have to be a timestamp though, anytime you have ordered data, really. And the as-of join is a join between two tables that ask the question. One of the tables is usually a regular set of timestamps or calendar dates, and the other table is just a bunch of measurements that are taken whenever. And the as-of join question is, for every regular calendar date in the calendar table, look up and find the most recent data value as of that date, and return that. It's a really simple question to ask, and it's ubiquitous in time series analysis. And as you can imagine, every time series specific database solves this problem one way or another. The one that does it the best is KDB, which is the oldest, one of the oldest and best time series databases. But they all have some version of this coded into them. And you can solve this problem very efficiently as well in R. And conceptually, the problem can be thought of many different ways. Two in particular come to mind for me. One way is to think about it as like a non-equality join, where you're rolling along, for every calendar date, you roll through the data dates until you find the next to last one that's earlier, or you find the date that's less than or equal to the calendar date, and that's the value you pick. So it's kind of a rolling non-equality join on date. And the other conceptual way to think about it is to just do a full outer join between the tables on date, which would introduce a bunch of missing values where they don't line up, and then to impute those missing values with piecewise constant values along the value, and then to pick out the dates that you're interested in for the calendar after that. So those are kind of two different conceptual ways. And in R and Python, they both are one-liners, and you can do them many, many different ways. So here's three different ways, but there are many others. You can use a data table to do the rolling join approach, the non-equality kind of rolling join. Pandas has a merge as of function, which is the same as data tables rolling join conceptually. And then another way to do it in R is to use the XTS package. The XTS package can solve this problem in a number of different ways, but here I'm using that kind of piecewise constant, outer join approach. And that link there shows you lots of detail on this problem. So I tried to solve this problem, and I've worked on this problem before, in my career, actually at a database company. And I actually didn't know how to solve this problem in SQL though. So I searched the bowels of Stack Overflow for a long time last week, trying to figure out how to solve this problem. And I could not come up with a single example of anybody solving this problem in SQL. Every single solution I found had some sort of a custom function that was specific to a certain database, like some Microsoft SQL Server thing that could do it, or some special Postgres way of doing it, or some Oracle whatever approach for solving this problem. But I couldn't find just a generic ANSI SQL approach. So I turned the internet off, which is easy to do out here where I am, and wrote the query myself, mostly out of frustration and eventually out of spite after trying to write it so long. And this is the SQL query that I came up with that solves this problem. Remember, this is a one-liner in Python or in R, right? But this is what you need to do in SQL to solve the problem. Maybe if you're a SQL expert, you can show me how to structure this query so that it runs better, but I'm not sure that it can be done. But I'm open to any suggestions, so please feel free to send me a pull request with it. Tell me I'm an idiot and give me better SQL for solving this problem. But this will actually do the as-of join. And how does it compare to R performance-wise on my laptop? So I took that example I just showed you with the two tables, and I just scaled them up. So I had 5 million data observations and 250,000 calendar entries. So it's still a tiny problem, right? It's just a couple megabytes. It easily fits in my laptop's memory. It's not a very big problem. And you can see XTS and pandas on my laptop almost instantaneously give me the join in about 70 milliseconds. And this is averaged over like 10 runs. And data table was also super fast, although noticeably slower at 110 milliseconds, if you can call that slower. The SQL approaches, both in SQLite and DuckDB, though, with my unspeakably horrible query on the previous slide, they run pretty slowly, about 700 times slower than R in this example. So the moral of this story, I guess, is don't use SQL for time series analysis. Maybe people would have told you that already and saved you from this viewing this horrible query. But once you start to hear SQL's not good for that problem, or it's not good for that problem, after hearing that so often in my life, I start to wonder, well, what is it good for? And I don't think it's really good for much. That gets back to that syntax slide. So from a pure performance standpoint, I ran a bunch of different examples, and I'll send later. There's a link to these things written up carefully, and I couldn't find a single example for in-memory problems that R was, or that DuckDB or any database for that matter, with one exception, any kind of database that you could use directly from R, where R was slower. So R is just faster than DuckDB for every in-memory problem I could throw at it. But that doesn't mean you shouldn't use databases or DuckDB. DuckDB does have a great advantage in that you can write a dplyr expression that would work fine on in-memory data. But what if you have a data set that's like 300 gigabytes or something like that? You probably don't have a laptop with 300 gigabytes. And that's where DuckDB really has an advantage, because you can take that same dplyr expression and run it on data in DuckDB, and it'll run very efficiently on that out-of-core data and give you an answer. So without changing any programming or thinking about your problem or splitting it up or anything like that. So it has a really nice advantage for larger than memory, main memory data. So my advice here from a performance standpoint is use databases for problems that don't fit in your RAM. And when you do use them, you shouldn't probably use SQL. You should probably just use dplyr because it's better. And it'll work more universally across all the databases anyway. Except, there's always an exception. And I write about this in that example there with the New York taxi data set, which is a very large data set. If you're doing a one-off analysis where you're just going to churn through a bunch of CSV or Parquet files or whatever you got, and you're just going to do it once, and you don't plan to do a bunch of repeated analyses over and over with the data, but you just have truly a one-off problem, then you probably are best off using Jim Hester's Vroom package. That'll best off in terms of overall time spent working on the problem, because it can take quite a while to get CSV files, for example, into the database. And you can completely avoid that parsing step with Vroom by just working your analytics directly on the CSV. But this is kind of a special case. It's only good for one-offs. But it's like I think this was in Don Quixote. It takes all kinds of tools to solve your data science problems. I'm not so good with Castilian Spanish, so maybe it was not quite translated like that, but I think it was translated like that. So in summary, DuckDB is, in my opinion, I think it's the easiest database to use from R. I mean, it's just install packages DuckDB, no dependencies, library DuckDB, and you're ready to roll with a full-blown relational database. You can do whatever you want with it. Hannes and Mark have succeeded brilliantly in reducing the friction to using a database from R. The key advantage of using such a database is when you have problems that aren't going to fit in your RAM, and then you can throw the database at it without having to rethink your problem, because the database knows how to do that for you. And probably you don't want to use SQL. You probably want to stick with using dplyr, because then you could use it with R or with the database or wherever. And so I wrote up all that and many other examples in that link down there. And you can read about all these things in great detail. There's one more thing. There's just this stupid performance thing. I noticed when I was doing performance testing, it's not like the old days, right? These new machines that we're using, the CPUs don't even have like fixed frequencies anymore. They do all kinds of weird performance and thermal and power saving management, and their CPU frequencies bounce all over the place, kind of on demand by default, which really makes it tough to benchmark stuff repeatedly. Even when you're doing a lot of repetitive tasks, if you happen to have something that gets stuck on one CPU for a while, the other CPUs will change their frequency, and then all of a sudden you have more threads firing. It really messes with performance testing. So here's a tip to mitigate that to some extent. It doesn't fully solve the problem, but it really helps make repeatable performance tests. And you basically, in Linux, you can tell your CPUs to run to full speed all the time with that one line there. So this is a little tip for performance testing. And I'm happy to answer any questions, or if you want to swear at me for talking bad about SQL, that's fine too. It's whatever you want. Thanks. Questions, Amy? No questions. I know you're still reeling from seeing those queries, right? It's just they
was something.
You. Yeah.
Yeah, I don't think you inspired anyone to start learning SQL today.
Well, I had one question. For problems that are larger than RAM, when you read with DuckDB, and let's say you're done with a query, you close your session, and but you want to save it, so like next time you want to open it, is there a way would you recommend like just saving like the space, the R space for future loading, or just reading again a large CSV file with DuckDB?
No, sorry, that's a great question. Yeah, if you're starting out with something like a raw data format like CSV, you want to process that one way or another. You can do it in R, load it into a data frame, and then put it in the database. The databases also have facilities for directly reading raw data file formats like CSV, Parquet, many others, into the database format, and then storing that into a file on disk for you that you can then reuse. It's already parsed and much faster you don't have to reparse it, right? So that's why Vroom only works for one-off problems, because it has to parse it every time. But the databases, they can parse the data once, which is expensive, but then it's basically instantaneous to start doing analytics on it the next time you want to use it. So, DuckDB uses something from Postgres called copy to read in CSV files from disk. So you can use this copy statement. It's not a SQL statement. It's a data, it's a direct data manipulation statement unique to the database. But then that'll store it in a file. So every database you have in DuckDB is either in memory, so it's ephemeral, or you can, when you do that register DuckDB statement, you can register it with a file on disk anywhere you want in the local directory, wherever you want to put it. And then the next time you run your session, you can just refer to that, and you don't have to parse it anymore. It's ready to go. Does that answer your question?
Yeah, perfect. Thank you.
Sure. I should add that DuckDB's parsing of CSV is good. It's not as fast as R, but it is it's much higher performance than well, actually Postgres has improved very recently. Postgres is also very good. So I mean, it's good. It has fast CSV parsing. It can also read a lot of other file formats directly. It can read Arrow files and Parquet files. Arrow is becoming the kind of lingua franca of data interchange right now. Yeah, so it natively works with Arrow files as well. It's quite a cool system. But again, really restrict your use of databases to larger than memory problems, and just avoid SQL unless you're doing something real simple.
And are you thinking of having an extension of DuckDB that's not a relational database, like a NoSQL version of DuckDB?
Well, I'm not a DuckDB.
I know, I know.
There are lots of
Oh, you're aware.
non-relational embedded databases, and some have nice R integrations. So the grandfather of them all, or the grand person of them all, is it's Berkeley DB. It's key value. It's very high performance key value database. It's an embedded database system. It's a NoSQL embedded database that's a key value store. It uses B trees, and it's open source with some kind of weird license. I think because of Oracle's involvement with it, but it's very good. Also, Redis has a nice. Redis isn't embedded. It's separate. It actually runs as a server, but Redis is a really nice database. A lot of people use R with Redis quite a bit. There's also LevelDB, LMDB. There's lots of NoSQL databases that have nice R packages associated with them. LevelDB and LMDB are both embedded, just like Berkeley DB.
Nice. Thank you.
So you mentioned Python integration. Does Pandas have a similar backend like dplyr?
So there have been multiple attempts at this. There was a project about 3 years ago that got started, or less, maybe 2.5 years ago, that kind of seemed to stop at some point. There's a newer project. I forget the name. But someone serious has recently started looking at this problem. I forget the name. I think this person worked with Frank McCherry at Materialize, which is a pretty interesting database company. But they're no longer there. And I think there's a recent effort to try to get a dplyr for Python going. It's hard in Python because Python is not as nicely functional as R is, right? It's so object-oriented focused, although it does have closures now, but it's just more cumbersome in Python. However, the DuckDB people have done a lot to mitigate that. So DuckDB has a Python API that lets you chain expressions with the dot. They're DuckDB specific functions, in the whatever Python calls packages, library or whatever. But you can achieve a dplyr like syntax that's unique to DuckDB using the DuckDB Python package or library, whatever the module. What do they call it? Library, I guess. And it's pretty cool, actually. And there's still this zero copy stuff with Python as well, between DuckDB and Python. It's really quite impressive, actually.
Okay, cool.
Why did they call it?
On those slides to a talk by Mark at Cornell that's pretty interesting to look at, a YouTube link. Sorry, go ahead, Jay.
Oh, this is not an important question. I was wondering why they called it DuckDB, because I've seen packages like kind of funny names with like quirky little stories behind it, and DuckDB sounds like really specific.
Mark goes into that in his Cornell talk. Hannes is a very interesting guy. I met him a few times at like useR conferences, and he's pretty cool. And he lived on a houseboat, and I think the story is that he had it's not a pet, but this wild duck would hang out on his boat, and he would feed it, and it would like sit on his shoulder. He was like a pirate. And so I think they named the database in honor of this duck. Look at his talk. He talks about, he even has a picture of the duck in the talk, so there is a backstory involving a duck though.
That's awesome.
Yeah, it's a pretty cool thing. I mean, SQLite is also very good, and the R SQLite package is also great. But DuckDB is they're both really, really nice things to use when you have huge, like if you're that New York Taxi data set, it's like 300 gigabytes. It's enough to put on a SSD or something, but few people have 300 gigabytes of RAM to play with, right? So you either have to split the problem up, or you need something like a database to run through your problem. And there are advantages and disadvantages to each approach that I outline in those notes. If you do go to the trouble of splitting up a problem, like with map and reduce, like I did with that the airport thing. Then one advantage of splitting up a problem is that it becomes trivially scalable. Like if you want to run it on a cluster in R, you just use, a future package or for each or whatever, and magically it works in parallel on a cluster. So, there are advantages to thinking through a problem and splitting it up, but it's harder. You have to go to the trouble of thinking through the problem and splitting it up. With the database, you don't have to think about it. You just throw the problem at the database, wait a while, and get an answer back. It may not be as scalable though. So yeah, advantages and disadvantages to each approach. Still stupefied by that query, huh, Alec?
I know we're a little over, but could you comment on, I don't know if this is a trend or not, but columnar storage versus the row-oriented storage. What's the difference between them, and why is one preferred?
Yeah, so row-oriented, and it's the word relational and relational database refers to the relations on tuples, right? So you think of a row as a big tuple of data, right? You've got like, a bunch of elements. The next row has a bunch of elements, so kind of semantically, the row orientation fits the relational model very well. But in practice, the real reason that you follow one paradigm or another has to do with the workload. It's very, if you think, memory is linear, right? So in R, a data frame, you have the iris data frame, right? You have petal length and then petal width. And you see them as two columns, right? But it's really like this. It's in memory, there's petal length, and then maybe, well, actually, they're pointers. They really are separate columns in R. They're just separate. They're separate, right? But when you store it on a disk, when you serialize it, it becomes like this, right? Because you can't, the disk, you don't have 50 files or 5 files for each column. You have a single file. So you have petal length, petal width, sepal length, sepal width, and species, right? You've got the iris database as one long column, and then you put it back into a matrix or a data frame in R. So columnar data is great if you need to get to a whole column at once. Like if you want to do averages across the columns, well, each column is like, there it is, there's a whole column. I can do one memory map or one data load, and I got that like that. Because sequential reads are very fast out of disk or even memory, right? So for things that involve statistics on columns, columnar, which is what we usually call analytics loosely, columnar data formats are preferred. On the other hand, if you've got a transactional processing, so they call that online analytic processing, the A for columns, OLAP, right? On the other hand, if you're imagine your Visa or a bank or something like that, and you've got, Visa has something like 1,000 transactions per second coming in, right? They need to write every one of those transactions into a database. Well, if they're all stored on the disk like this, then you have to make room. You want to add a new row, you have to somehow shift this column down to put a new value. It just doesn't work, right? The columnar format doesn't. But if everything is stored row-wise, it's just append to the end of the file a new row, right, of the new updated data. So it happens instantly. So if you've got a write-heavy workload of tuple data, of rows, basically, that's called transaction processing typically. And you think of credit cards and stuff like that. And anybody who's doing a super write-heavy row-wise workload. And in that case, you want to store stuff row-wise, because otherwise it's impossible, right? It's the only efficient way to do it. So that's why those two formats will always exist. They will, both of them have their own purpose, and One's optimized for one use case and another is optimized for another. It's very difficult to come up with an overall optimum. These days, you see things like Arrow, and Arrow in particular is a beautiful approach. It ends up being serialized, like it's a columnar approach, right? But it ends up being serialized in a columnar way, but it's done extremely well, and it makes it it does give you a bit of a compromise between those two. It's really, but the beauty of Arrow is its serialization is free. It basically uses an in-memory data format, so there's like zero cost serialization with Arrow. That's why everybody's switching to it for columnar stuff, right? But you're never going to get rid of transaction processing workloads. But that's the difference between the two in a nutshell.
Thank you so
I
much.
could go on forever, but I'm not a database expert, by the way. I used to work at a database company, but that was a long time ago.
Okay, any remaining questions? All right, no. All right, well, thank you very much, Jay and Bryan, and thanks everyone for attending and all the questions and everything, and hope to see you at a future event.